of a quadratic polynomial if 2 and 3 are the roots of some quadratic equation p of x is equal to 0, then by the factor theorem x minus 2 and x minus 3 are the factors of p of x. Therefore, one can take function p of x is equal to x minus 2 the whole multiplied by x minus 3, but the roots of d p of x is equal to 0, d is not equal to 0 are also 2 and 3. And at the same time, the quadratic polynomial can have only 2 factors. According to the factor theorem, function p of x is equal to d into x minus 2 into x minus 3, where d is a non-zero constant. Thus, in general, if alpha and beta are the zeros of a quadratic polynomial p of x, then p of x is equal to d into x minus alpha into x minus beta. Illustration. Find the quadratic polynomial function p of x whose roots are 3 and 5 and coefficient of x square is 2. Function p of x is equal to d into within brackets x minus 3 into within brackets x minus 5. The coefficient of x square is d. Therefore, d is equal to 2. Hence, p of x is equal to 2 into within brackets x minus 3 into within brackets x minus 5.